In this demo, we discuss the configuration of trunk interfaces and setting up native VLAN on Layer 2 switches. Layer 2 switches support one of two interface modes, either access or trunk. An access interface supports a single VLAN and is used to connect to non-switching devices, such as workstations, printers, possibly routers, but not other switches. A trunk port, on the other hand, carries all the VLANs of that switch by default. It is also used to connect to upstream switches, such as from an access switch to a parent distribution switch over uplink ports. Because of this, you should be careful when configuring trunk interfaces. They can affect a larger number of devices versus reconfiguring an access port. We'll start with a couple basic show commands. First, we'll type show interfaces trunk. Now, before we press enter, we want to make it clear that switches will try to negotiate trunk connections automatically. We haven't configured anything on the switch regarding trunk operation, yet when we press enter, you'll see that port GI01 is, in fact, in a trunking status. Its mode is auto, which means it dynamically negotiated a trunk connection with the devices that connected over that port. We can also see its encapsulation type is 802.1q, which is the standard frame tagging method used on switches today, both Cisco and non-Cisco. Its native VLAN is 1. These are all default settings. We can see that all VLANs would be allowed on this trunk and that the specific VLANs that currently exist on this switch are also allowed and active on this trunk connection. You do have control over this, which we'll see later. We'll use another show command. Let's type show interfaces and this time add the status keyword. Press enter. You'll see a whole screen of output. On the bottom, we can once again verify that GI01 is currently configured as a trunk. We see that its duplex and status have been automatically negotiated to be full and 1000 megabits per second. We could have honed that command down and identified the specific port followed by status. In that case, only a single port output would show up. The trunk interface came up automatically. Let's talk about how you'd configure trunk negotiation or manually set the status of a trunk connection. We go into Global Configuration and then to the interface by entering Interface G01. From here, we'll type switchport mode followed by question mark and press enter. You'll see three options listed here, access and trunk, of course. Those commands would be used to unconditionally, or manually, if you will, force this interface to be one of those two modes. If we type switchport mode trunk, you're telling the switch that you don't care what the other side is configured. You want the switch to come up as a trunk on this end. In this case, you're not depending on dynamic negotiation using the Dynamic Trunking Protocol, or DTP. If we did want the switches to negotiate, we could set that to dynamic. Then we'd have to pick one of two options, auto or desirable. All you really need to know about these is that if both ends of the connection are set to auto, then the trunk will not become active. Auto configuration will not bring a trunk connection up. If we have any other combination of values between the switches, for example, one switch was set to auto and the other was set to desirable or trunk, then the interface would come up as a trunk connection. To demonstrate that, we'll change this to desirable and press enter. We'll then enter shutdown. Then we'll enter no shut on this interface to bounce it. Okay, we want to use the show interfaces trunk again. We'll enter do show interfaces trunk to execute the command from within config mode. You'll see that the mode is desirable on this end, but is still operating as a trunk connection. Again, you'll notice that the VLANs currently allowed on this trunk are all the VLANs that are currently active on this switch. There might be a reason that you didn't want that. For example, VLANs 100, 101, and 105 are not present or being used on the parent switch that the trunk connection leads to. Maybe there are no devices within those VLANs upstream over this trunk connection. For that reason, you wouldn't want broadcast traffic originating from those VLANs to be sent over the trunk. You can enter switchport trunk allowed VLAN question mark. If you look at the options here, you'll note you can add or remove VLANs. In this case, we want to remove 100, 101, and 105. We'll enter switchport trunk allowed VLAN remove 100, 101, 105. Now we'll enter show interfaces trunk. We see that the allowed VLANs have been cut down to only 1, 10, and 110. Finally, notice that the native VLAN was set to 1. The native VLAN is the VLAN over which frames will not be encapsulated by 802.1q. They will not be frame tagged when traversing the trunk. Instead, they're sent in their raw form with no 802.1q header. We can change the native VLAN on a switch using a similar command to what we just used. We'll use switchport trunk ? Note there's an option for native. Let's say we want to change that to VLAN 10 so that any traffic originating from VLAN 10 when crossing this connection will not have a tag assigned to it. Let's enter switchport trunk native VLAN 10. Let's end out and type show interfaces trunk one more time. You'll see that the native VLAN has in fact been set to 10. If you do set the native VLAN on one side of a trunk, you want to be careful that you perform the same thing on the other side. We just did this on switch A. You want to go into switch B at this point. Now go to its trunk interface and execute the same command to switch that one to native VLAN 10 as well. That's it for this demo. In this demo, we configured a native VLAN assignment.